Hey guys, today we're going to look at 4.2 day 2, and what we're going to be doing today is we're going to be graphing polynomials. So far, now we've kind of sketched polynomials, but today we're going to be a little bit more precise. So far we've talked about how to find like the x and the y intercepts of a function, what the graph is doing at the x-intercepts, so like does it cross through or does it touch and then turn around and go back the way it came. We've talked about the end behavior and the number of turning points that the graph can have. Now, these turning points would be like a local minima or a local maximum. So if the graph goes up and then turns around, that's a high point in the graph, so that's going to be a local maximum value. Okay, likewise if it goes down and then curls back up. These minimum maximum values are the only thing that we have not found yet. So that's what we're going to be doing today. So everything else is the same. We're going to find x-intercepts, we're going to find y-intercept, we're going to know which way the graph's going, up and up, down and up, whatever. Okay, but today we're going to find those minimum maximum points where we're actually going to go up, turn around, and then start heading back down. Now, in Unit 1, we talked about something that was called the difference quotient. And you may remember this function right here. And I told you that this is calculus. This is going to be calculus that we're going to be using to find these minimum maximum values. Okay? This difference quotient is just the slope formula. If you're given 2 points on a curve, okay, so we'll say this point is x and f of x, which would be the y value of this point, but it's the function evaluated at x. And then I've got this point that's a certain distance away from this x value. So they're going over h units, so this would be x plus h, and this would be the function evaluated at x plus h. So this is the y value that goes with this x value, and this is the y value that goes with this x value. So the slope formula, which is y2 minus y1 over x2 minus x1, that you learned in algebra, looks like this. Okay, that's the difference quotient. That's all it is. And it finds a formula that will tell you the slope at between any 2 points. And this is called a secant line. When you have a line that goes through a graph twice, that's called a secant line. Okay? Now, if you imagine these points getting closer and closer and closer and closer together, and we're still using this same formula, this gets closer and closer to finding the slope at 1 point. Just one precise point, that would be the slope of that point. As these two x's get closer and closer, and this h value kind of shrinks and disappears. Okay, that's going to be important in a second. Okay, so the derivative essentially finds you the slope at a point. Okay, so these are 2 examples we did in Unit 1. This was in your notes, and I think this was one of your worksheet problems. So we took this function, we applied the difference quotient to it, and then there was a whole bunch of steps, and we got this answer. Okay? So this is essentially this is the derivative. But remember what I just said. As these 2 points get closer and closer together, and essentially this h starts to disappear, that's the derivative. So imagine this formula with this middle term disappearing because this h is getting really close to 0. So essentially it's going to disappear, and we're left with this. That's the derivative. That formula will find you the slope at any point on this function. So imagine this is your graph of this function. It's not, but imagine. Okay? If I put a 1 into this function, I would get a positive number because this point's going to have a positive slope. If I put a 3 into this function, I'm going to get a bigger positive number because this has a more positive slope. It's starting to like really curve up. And if I put a -2 into the function, well, right here the graph is going down, so that's going to have a negative slope. Okay? Same with this one over here. This is a function that you were given in your worksheet. We did the difference quotient, and we got this. Again, if you imagine this h disappearing, then that's going to leave us with this, which is the derivative. Okay? So these 2 equations are the derivatives of these 2 functions. Now, compare them. Take a look and see if you see anything about them that looks similar or different or whatever. because this is how you find the derivative. So we're going to cut out all this work that we had to do, and we're going to do it real short and sweet. If you take this exponent and multiply it by this coefficient, you get this number out here. If you take that exponent that you just multiplied and lower it by 1, now you have the x. And if you take this exponent, which is just a 1, that's what you do every step. You take the exponent, multiply it by the coefficient, and then you reduce the exponent by 1. Well, that 1 is now going to be a 0, so we're not going to write it. It's going to disappear. Same thing over here. 2 times 1 is 2. Reduce this by 1, and you get x to the first. This is a 1, and this is a 1. So 1 times 1 is 1. Reduce this by 1. Now we have x to the 0, so we're not going to write it. This constant already is x to the 0 power. So 0 times 4. So that just disappears on us. And that's it. That's your derivative. So in this box, these are the rules for how to find the derivative. Okay, for each term, multiply the exponent with the coefficient to obtain your new coefficient and reduce the original exponent by 1. So the derivative, without having to do the crazy difference quotient formula, is just 3 times 2, 6. Reduce this by 1, x to the first. Take 1 times 9, or negative 9, so it's going to be negative 9. Reduce this by 1, so this is x to the 0, so we're not going to write it. And then your constant just disappears. That's it. That's the derivative. We write the derivative with a little prime notation, and that's how we tell the difference. Okay, so this one, f prime of x, will be 2x. 1 times 5 is 5. And then that disappears. That's it. That's the whole thing. So see if you can do that one. So pause it if you need to. Okay. You should have got 6x to the 5th minus 12x cubed plus 6x to the first. And that's your answer. Those are the derivatives. Okay, so we're going to be using this in a second. Alright, so how does this tell us anything that what we're doing with the graph? Okay, look at this graph over here. So these little lines are tangent lines to a certain point on the graph. Okay, so here's a point right here. This line goes through it. That obviously has a negative slope to it. But look at this local minimum and look at this local maximum. The tangent line is flat. So what would the slope of that be? Well, the slope of a horizontal line is 0. So in other words, if we take our derivative, f prime of x, and set it equal to 0, we can find at what points, at what x values, does our slope equal 0. And anytime you have a slope of 0, that means you are at one of these local maximums or local minimums. And that's what you do with the derivative. And that's going to find these high or low points for us. Okay? So to find a minimum or a maximum, we're going to find the derivative of the function, and then we're going to set it equal to 0. And then we're going to solve it. Okay? That derivative could be a quadratic. It could be a quadratic that factors nicely. It could be one that doesn't factor nicely, and we have to use the quadratic formula, but we can do that. Okay? And those are going to be our x values where we have local minimums and maximums. Then, to find, like, what are those actual points? What are those high points and low points? We're going to take those x values, and we're going to put them back into the original function. Okay? The derivative just finds us where our slope is 0. But if we want to know what those actual y values are, like how high and how low do I need to go to find those minimums and maximums, we're going to put that back into the original. Okay? So let's do this first one, and you'll see what I mean. So here's my function. And so the first thing I'm going to do, so all we're doing right now is we're going to find the maximum minimums. We're going to find where those points would be located. So I'm going to find the derivative, which will be 6x squared minus, it'll be 1 times 24, so 24. This is x to the first, so we're going to reduce it by 1, so it's just going to disappear. And then your constant always disappears. So that's it. That's our derivative. So we are going to set this equation equal to 0, and we're going to solve it. Well, the first thing I'm going to do is I'm going to factor out this 6. 6x squared minus 4 equals 0. And then now this is the difference of squares. this factors into x plus 2, x minus 2. So x equals negative 2 and positive 2. Those are the two x values that make this equal to 0. Okay, so that's where my local minimum and maximums are. So now we're going to plug them in. We're going to plug them into the original function. I'm going to put f of negative 2 into this function. So 2 times negative 2 cubed. So these are the x values. Now we're trying to find what those y values are. What are the minimum or maximum values? So this is cubed minus 24 times negative 2 plus 12. So plug them all into that. You can put that in your calculator. You could probably do that in one step. As long as you use parentheses, put that in your calculator. And you should get 44 as an answer. So the point negative 2, 44 is one of my minimum or maximum values. Now the fact that that y is a 44, that tells me this is probably a max. Okay, that's going to be a high point in our graph. Then I'm going to plug in the 2. We're just going to plug each one of these into the original formula one at a time. So 2 cubed minus 24 times 2 plus 12. And again, plug that all in your calculator, simplify, and you're going to get negative 20 as an answer. So again, the point, so this is 2, negative 20 is going to be one of my, and again, negative 20. So that's probably going to be a minimum value since we're all the way down at negative 20. Okay, so that's going to be the high and the low point of this graph. And then we can point those, we can graph those, and now we're not guessing where the graph curves. We're actually going to know where it curves. Okay, so take a look at number 2. Actually, why don't you see what you can do on this one? So hit pause and try to do the derivative, set it equal to 0, and see if you can solve it. Okay? So hopefully this is what you got when you found the derivative. If you're setting this equal to 0 and solving, the first thing you'd want to do is factor out an x. Actually, factor out a 4x. Factor out that 4 as well. And that'll leave me with x squared minus 1. This is the difference of squares again. So this is 4x, x plus 1, x minus 1. And so this actually has 3 places where the slope is 0. X equals 0, negative 1, and positive 1. Okay, so we're going to take each of these 3 points, put them back to the original equation. So we're going to put f of 0, well, that would just be 1. We're going to put f of, we'll do negative 1. So we're going to put negative 1 here. So negative 1 to the 4th. Negative 1 squared plus 1. And you're going to simplify that. So put it in your calculator. You're going to get 0. And then we're going to put in a 1. Positive 1. And again, that's going to give us 1 minus 2 plus 1. It's going to give us 0 again. Okay? So these 3 points, 0, 1, negative 1, 0, and 1, 0 are going to be our local minimums and local maximums. So that's a high point, so that's going to be a maximum, and these are both low points. So that's going to be a minimum. Keep not showing my answers. Sorry about that. Okay? All right, so let's take a look at this last one together. So again, my first step is I need to find the derivative. So we're going to take 3 times 2, 6x. We're going to reduce that by 1, so that'll be squared. Then we're going to take 2 times 5, that's 10. Reduce that by 1, that's x. And then 1 times negative 3, and that's it. Okay? So the idea is we need to set this equal to 0, and then we need to solve this quadratic. Well, we've got a leading coefficient of 6. We've got a negative 3. So you could put, your 2 sets of parentheses, and you could do guess and check. You could do factor by grouping. Now, if you do factor by grouping, or if you do guess by check, you can check something right now. If you take 6 times negative 3, you'll get negative 18. And then if you try to find factors of negative 18 that add up to 10, you won't find them. Okay? And what that tells us is this does not factor. It doesn't factor nicely. Okay, so if you come across a quadratic and it doesn't factor, you're going to have to use the quadratic formula. Okay, so again, quadratic formula, x equals, so this is the one we're looking at. Don't look up here. So this is what we're looking at. So negative b, so negative 10, plus or minus the square root of b squared. Well, if you'll let me, I'm going to go ahead and write that as 100. Minus, and then 4 times a times c, and then all of that over 2 times a, so 6. Okay, now we could simplify that. Negative 10 plus or minus. If you take the square root of all of this, you're going to get 13.11-ish divided by 12. And so you've got two answers. So here's our two answers you normally get when you factor, but this one doesn't factor. So negative 10 plus 13.11 divided by 12, and negative 10 minus 13.11 divided by 12. If you're going to plug this into your calculator all in one step, put parentheses around the numerator, and then your calculator will know to do this addition or subtraction first, and then save the dividing by 12 for last. But when you do it, you'll get two answers. You'll get 0.3-ish, and you'll get like negative 1.9. Okay, so those are the two x values where our slope is equal to 0. So now I could put 0.3, so I've got to put a 0.3 back into that original function. So 2 times 0.3 cubed plus 5 times 0.3 squared minus 3 times 0.3. Okay, so put that in your calculator, and you're going to get negative 0.4, and then put negative 1.9 into your calculator. So again, put it in for your x's there. Be sure to put parentheses with the negative so that your exponents treat the negative correctly. And when you do that, you'll get 10.03 about. Okay, so this 0.3 negative 0.4 is going to be a local minimum because it's negative 0.4. And then this point, negative 1.9, positive 10.3, 10.03, will be one of our local maximums. Okay? All right, so now let's put everything together. So we're going to graph this function correctly. So the first thing we're going to do is, well, we're going to make note of the end behavior. These two you could do either way. Okay, make note of the end behavior, x cubed. I know this graph is going to go up and down like that. Okay, that's what an x cubed does, just like a S-curve. Okay, that's where the ends go. Find the y-intercept. Well, that's the constant over here, so negative 1. So I know this graph goes through negative 1. I know where the ends are. Now I want to find the roots. So I want to find the x-intercepts. So, all right, so we need to do our p's and q's. So factors of negative 1 over the factors of positive 1, that's just going to be positive or negative 1. There's not a lot of options on this one. Okay, so start testing, test something. I'm going to test a 1. I'm going to hope that that works. So 1. So this is a 1, negative 4. Sorry. Positive 4, negative 1. So bring down my 1. 1 times 1 is 1. Negative 3. 1 times negative 3 is negative 3. Add them. 1. 1 times 1 is 1. And negative 1 and 1 is 0. So that worked. I have a remainder of 0. So this is one of my, remember, we're finding x-intercepts now. So that's what this is. We're finding x-intercepts. And I know that positive 1 is one of my x-intercepts. And I also know when you divide this polynomial by x minus 1, you get this, which is x squared minus 3x plus 1. Now again, we need to break this down. This does not factor. There are no factors of 1 that add up to negative 3. So whenever that happens, just use the quadratic formula. So negative b, so that's going to be 3, plus or minus square root, negative 3 squared, just go ahead and write 9. Don't put negative 3 squared. You may forget to put the negative in a parenthesis. Minus 4 times 1 times 1 all divided by 2a, so 2. Okay, so put that in your calculator. Simplify this if you want. Like go over to the side and just figure out what the square root part equals. So this is 9 minus 4, so this is 5. So whatever the square root of 5 is, you could put that down over here. And then do 3 plus that answer divided by 2, and 3 minus that answer divided by 2. If you do it all at once, I'd put parentheses around the numerator so your calculator makes sure to add or subtract those together before it does the division by 2. So please try to do that. Don't just copy down what I'm writing. 2.62 and 0.4, or 2.6. That's fine. Okay, that's what you get when you plug that in your calculator. Okay, so make sure you practice that and make sure you're getting that answer because you're using parentheses correctly. So what do we have? We have x-intercepts at 1. That's the first one we found. At 2.6 approximately, and at 0.4. A little bit less than half. All right, so that's what we know. We also know that the ends of this graph are going to go down, and right here it's going to go up. I don't know exactly what that's going to look like, but yeah, something like that. Now we got to figure out what's going on in the middle. Okay, so we are going to now find, so that's what we've done already. We've done that on other days. So now I'm going to find the derivative so we can find our high and low points. So 3x squared minus 8x plus 4, that's our derivative. We're going to set that equal to 0. This is a quadratic, so we're going to see if we can factor this. This does factor. If you do 3 times 4, you'll get 12. There are factors of 12 that add up to -8. It'd be like -6 and -2. So you can do the factor by grouping if you want. I'm just going to do guess and check. It's a 3x and then x. And then I need to get a 6 and a 2. So that's going to be a 2 and that's a 2. I need to make both of them negative. So -6x, -2 gives me my -8. So that's right. Which means that x equals, so for this to equal 0, it would be positive 2/3 for x. And for this to equal 0, it'd be 2. So that's where we have local minimums and maximums. We just don't know what those minimums and maximums are until we plug them into that function. So we're going to find f of, let's do the easy one first, f of 2. So we're going to put a 2 into that function. So put it right in your calculator. 2 cubed minus 4 times 2 squared plus 4 times 2 minus 1. Okay, you can put that all in your calculator. You're going to get -1 as an answer. So so our graph goes through 1, 2, -1, and that is a minimum, obviously. And then we also need to put 2/3. If you want to put 0.667 or something like that into your calculator, that's fine. Okay, that'll give us a close enough approximation if you don't want to put the fraction in there. So again, put that in your calculator and you're going to get 0.2. So go over 2/3 and then just barely go up. So our graph goes up. That's the local maximum. It comes down. It hits this local minimum. It curls up. And that is the exact graph of that polynomial function. Okay? Now, I want you to try this one to the best of your ability. Okay? I'm going to give you a hint. Now, this is an x to the 4th. So there's going to be 4 x-intercepts you have to find. Okay? And it probably means there's going to be 3 values where we're going to have local minimums and maximums when you do the derivative. I'll give you a hint right away. If you've got to factor this, see how you've got a negative out front? Now that negative tells us something about the ends of the graph. X to the 4th, when it's even, they go in the same direction. But that negative is going to make them flip. So I know the ends of this graph go down and down. And I know this graph is going to go through -6. 1, 2, 3, 4, 5, 6. There's my y-intercept. So now I got to find the x-intercepts and I got to find the local minimums and maximums. Before you try to do this, factor out a -1. That will make life much easier. Minus 3x squared minus 7x plus 6. That's what you want to factor, not with that extra negative in there. Okay? So you're going to have to do p's over q's. Figure out all the factors of 6 divided by 1. That's going to be positive or negative 1, 2, 3, and 6. So those are the only numbers that work. So we're going to test those and we're going to see what works. I would probably start with a 1, okay? And if that works or doesn't work, I'd try a -1 or maybe a 2, okay? So I want you to try this to the best of your ability. I am going to work it out, and then I'll show you what I did afterwards. But see how much you can do without watching the video, okay? I'm pausing now. All right, so here's the first thing I did. Okay, so I factored that out. I found my potential zeros, and I started testing them. I found that 1 worked. Okay, so now my x to the 4th has been chopped down to an x cubed. That means I'm not ready to factor yet using good old quadratic methods. I have to find another 0 that works. Now, I just happened to try 1 again. I knew that 1 was going to work again. So I tried 1 again. It worked. So what that means is that 1 is one of my x-intercepts, but it appears twice. So this is going to be one of those instances where the graph goes and touches the 1 and then turns around. It doesn't go through it. Okay, that's going to be important to know. But then that brought my x cubed down to an x squared, and then I could factor this. This one factored, if not, use the quadratic formula, but this one factored nicely, and so I now have these 4, now 2 of them repeat, but I have these 4 x-intercepts. So I have -3, 1, 2, 3. I know my graph goes through -2, and then I know my graph goes through 1, and that it touches there. Now, I'm going to tell you something. If you know your graph touches at one of your x-intercepts, if it touches and turns around, that means that point is also going to be one of your local minimums or local maximums. Okay, that's a big hint for this next step. Okay, so the next step is to find the derivative, solve it, set it equal to 0, and then find those local minimums and maximums. Okay, so I'm going to pause the video again, and then I'm going to complete it. So you try to finish if you haven't already. All right, so there's my work on the derivative. So there's the derivative. Again, I needed to find the zeros of this derivative. So I factored out that negative. I did not want that negative in there, so I factored out a negative. These are my p's over q's. I've got factors of 7 over factors of 4. So these are all my possibilities, but let's face it, we're going to find something here. We're going to hope we find a nice whole number, like a 1 or a -1 or even a 7 or a -7 before we deal with the fractions. Okay, I tried 1 and it worked. Okay, I got a remainder of 0. So 1 is one of my zeros, which I told you it would, because of the fact that that's a turning point. Okay, but then it left me with a quadratic that did not factor. So I used the quadratic formula. I got these two values, -0.7 and -2.6. I plugged -0.7 into the, remember, we're going into the original function to find our y values. So I plugged in a -0.7, I simplified that. I plugged in a -2.6, found that y value, and then don't forget about the 1, the first one we found. I plugged that in and I got a 0, which is what should happen. So what do I have? I have -0.7, so about here, and then -2.6. Okay. Oh, excuse me, -8.6. I was looking at this number, -8.6. So -7, 1, 2, 3, 4, 5, 6, 7, 8.6 down here. And then I have -2.6, 1, 2, and then up, 1, 2, 3. And there you go. Connect the dots. Make sure our ends go like this. We're going to go down. It's going to go up to this maximum. It's going to come down to the minimum. Turn. It's going to hit this. This is a turning point. And then we're going to go down. And that is the graph of that polynomial function. Now, that is a tough one. Okay, so if you need to rewatch that, do so. Try the ones on your homework. I tried to give you smaller ones, but I did give you a couple that were like x to the 4th just to challenge you. So take a look at your worksheet. Let me know if you have questions, okay? And we'll go over these in class. Thanks.